Welcome to Brain Vision.
Okay, so we calculate the work that went into this thing. So the work is the force times the distance. So that's force times the distance. And when the force is 10 newtons, the distance is 3 meters, then the work is 30 joules. We also know that when we're pushing something along a flat surface, all that work is then converted into kinetic energy. So that is kinetic energy, except that it's the delta kinetic energy, because there was already kinetic energy in this thing before we started pushing it. Right, so we need to know, so we use this delta kinetic energy to calculate the final kinetic energy. But in order to do that, we need to know the initial kinetic energy. So the initial kinetic energy is 1/2 mv squared when m is 7 kilograms, and the velocity squared, is 4 meters per second. So we can put that in. So 1/2 mv squared, and that comes out to 56 joules. Cool. So then the kinetic energy final is just the initial kinetic energy, this 56 joules, plus the changing kinetic energy, the 30 joules. So that's 86 joules. Right. Now, the kinetic energy in general, we need to find the velocity now. So the kinetic energy in general is 1/2 mv squared. So we can solve for v. We know that v is root 2 times the kinetic energy over m, the mass of the thing. All right, and this is using the final kinetic energy, because we want to know the final velocity. So put 86 joules in there, and this comes out to 4.95 meters per second. Cool. Now we have to get there with the kinematic equations that we learned from previous chapters. So the acceleration is equal to the force over the mass. That's just Newton's second law. Cool. So that's 10/7 meters per second squared. Cool. Now we can use our kinematic equation of motion here. So the velocity at a later time squared is equal to a velocity at an earlier time squared plus 2 times the acceleration times the distance it moved. So we can put all those numbers in there. So velocity 1, that's just that's our 4 meters per second, and then the acceleration, that's our 10/7 of a meters per second squared, and then distance is the 3 meters. So after we put those numbers in and multiply it out, we see that v2 is equal to 4.95 meters per second.